In this lecture, you'll get acquainted with derivatives and gradients. Actually, you know them already well. You'll see how. Gradient is actually the same as the instantaneous rate of change, whereas derivative is a different term. But often derivative and gradient are used closely in meaning. Here is a rule for calculating gradients. Its proof is very similar to what we did in the previous lectures when we were selecting steps and making them approaching zero by decreasing each time. If you want to see the formula's algebraic proof, there will be a link in the description below. So, if our main function is t squared, our derivative function equals 2 times t. If you remember, at point 5, our gradient was equal to 10. And, indeed, if we multiply 2 by 5, according to the derivative formula, we will get 10. At point 2, gradient equals 4, and at point 9, gradient equals 18. To sum up, at any point in time, gradient is different, but the function for calculating gradient is the same, and the name of this function is derivative. Gradient is the same as the instantaneous rate of change, or steepness of the slope of the tangent line, whereas derivative is just a formula without exact number. Here is a question for you. At which point will the gradient be equal to 0? Pause the video and try to answer. Keep in mind this. Hope you answered correctly. It's here, because at that point, the steepness of the slope of the tangent line is 0. That's all for now. See you in the next lecture.